Go, go, go.
All right, so 1/6 is inverse functions and logarithmic functions, okay? So we worked with both of these things last year, so hopefully this, for the most part, is all review, okay? I'm going to pull off to the side here and just start by remembering how to find inverse functions, okay? So let's say I ask you to find the inverse, which, by the way, the notation for that looks like so. And let's say my function is negative 2x plus 5. Okay. How do you find the inverse of any function? What is your first step? Okay, good. You start by switching the x and the y. Okay, so we'll say that x equals negative 2y plus 5. Okay, then what do you do after you switch the x and the y? Good, solve for the y. So you're just going to isolate it. So how would I isolate the y here? Subtract the 5. And then what? Divide by negative 2. So would everybody agree that my inverse function is x minus 5 over negative 2? Okay, I want to do one more just to make sure we understand this whole idea of a function first and its inverse. So let's do the same thing, different function. Let's do 3x squared minus 2. Okay, so how do I find the inverse of the second one? First step, switch the x and the y, so x equals 2y squared minus 2. Sorry. I was looking back at the last equation. 3y squared minus 2, thank you. Okay, so now how would I isolate the y? What would my steps be? Add 2, so I have x plus 2 equals 3y squared. Then what? Divide by 3, good. And then take the square root, perfect. Okay, so my inverse function would be the square root of x plus 2 over 3. Agreed? Awesome. All right, so finding an inverse algebraically, pretty simple. Okay, so let's take a look at the graphs, okay? They're going to ask you to find inverse functions doing it graphically, so without giving you a function. Okay, so I'm going to start by typing this into decimal so you can see when it happened graphically. Let's see, my first equation was negative 2x. Thank you. Okay, so we have this linear function that should not be a surprise with a slope of negative 2 and it's of 5 units. Okay, does anybody know what my inverse function is going to be in relation to my original? Okay, do you guys remember this? So there's a reflection involved. Okay, and the whole idea of this is that we switch the x and the y. So if I graph the equation y equals x, this red line, can you see how the black line would reflect over that? Do you see it? Okay, so give me a point on the inverse function. What's that? 5, 0. How did you come up with that? Okay, perfect. Okay, so all that Travis did is he took one of the points, 0, 5, and you just switched the x and the y, right? So we know that 5, 0 is going to be one of the points. Can you tell me another one? Need a little help?
0, 2.
0, 2.5. Okay, so 0, 2.5 would be about right there. Can you give me a third point? What's that? Negative 5. 5 right here. Hold on, I got this. Oh no. I'll never get it. Ooh, that's pretty good. Not really good. Maybe I should start over. Okay, so you said 5, 0, this one right here. Right there, right? And then 5, 5. Okay, let's type it in and take a look. Okay, so my inverse function was x minus 5 divided by negative 2, yeah? How do we do? Pretty good. Do you also notice where the functions like all intersect? Okay, so they all intersect at the same place. Yeah. So wherever my original function intersects my y equals x line, so will my inverse function. So we should be able to come up with 3 points pretty easy. All right, let's talk about the quadratic piece. Okay, let's go back into, what did I say? 3x squared. Oh gosh, that's not right at all. 3x squared. What did I say? Minus 2 or plus? Minus 2? Okay. So let me draw the y equals x line. So is anybody able to visually see the reflection that this inverse function is going to make? Can you draw it fairly accurately? Who said yeah?
What?
Can you draw it?
No.
You can't?
For my hand.
Oh, you can use your other hands.
I can't use my left hand.
Okay, can anybody do it? The inverse function.
If I mess up,
Let me see if I
you
can
guys don't know.
how to.
I can like switch the points.
Okay, it's frozen. So oh, I lied. It still works. Okay. Thank you. Okay, does everybody agree with how that would be reflected? No?
Yeah, I can draw it.
Oh, there we go. Your heel.
Okay.
Miraculously. Two fingers?
So I didn't know how to do it. Pretty close, right?
How come you only drawing half of it?
You can't have more than one x value. Good job, Tess.
Bruh, how did you know that?
So what you're saying is like the other half would make it like not a function? Oh, you just like walked right into where I was going with this. Okay. Okay, so let's try typing it in and see if Chaz is in fact right. You got some movement up there? Y equals x. Okay, what was the inverse? It was the square root of x plus 2. And then over 3. Hold on, I got this. It's like he's learned this before. Okay, so let's talk about that idea of not being a function. Is there a way that we could have restricted the original function so that it did in fact match exactly what Chaz has? Okay, by restricting the domain, right? So if we instead said, let me erase these lines. Okay, if we instead said, my parabola is only going to exist from where to where? Okay, going back to the original function, how could I restrict the domain so that it looks exactly like the function Chaz drew? For what x values? Less than or equal to 0? You guys are close. Less than or equal to 0? Greater than, because we would have this right-hand side. Okay, so if I restrict it to this right-hand side, okay, where I'm only drawing the right-hand side of that parabola, that's where x values are greater than or equal to 0. Okay, so x is greater than or equal to 0. So now tell me, what is the range of my original function? My range. Okay, so if I'm only drawing this first side, lowest value, -2 to infinity. So the range for that first one is from, actually I'm going to write this from -2 to infinity. I don't know why, I just feel like doing interval notation. Okay, tell me about now the range, or the domain and the range of the inverse function. They're flipped, right? So my range is now going to be from -2 to infinity. Oh, sorry, my domain. Blech. And my range is now going to be from 0 to infinity. Okay? So if I know my domain and range of my original, all I have to do is switch them to come up with my inverse domain and range. Okay? So we got that idea? That's what they're going to ask you to do on your assignment today. Okay, we okay with inverse functions? Super awesome. Okay, what else did they talk about? Ooh, they do a little bit of trig. Ooh, what's that? Just that? Oh no, that would be too boring. Oh, let's talk about logs. Okay, so you guys remember you worked with logarithmic functions in the past. So anytime you talk about exponential functions, they immediately lead into logarithmic functions because exponential functions are inverses. Okay, write this down. This is a big one. You will need to know this throughout calculus. You need to be able to convert between exponential and logarithmic form. Alexis asks, how do I solve this using logs? Okay, this is how you do it. Okay, if I have a base to the x equaling some y, okay, we can convert exponential form into logarithmic form. Chaz, you writing this down on your phone or what? Put it away. Okay, does anybody remember this form? X equals the log of base of y. Good. Okay, so you need to be able to convert between those flawlessly, okay, and that also gives you the ability to solve equations. Okay, so let's do a quick example of that scenario, just like this assignment that we saw today. I'm just going to make one up, so this might be icky. 4 to the x plus 2 equals 12. Okay, so this is kind of like what you saw on that problem. Well, those 20s, I don't remember what they were, but let's say you couldn't rewrite those bases. Okay, how would you solve this equation? Okay, x plus 2, the exponent equals?
Base 4.
Good, the log of base 4 of 12. Now, do you remember how to type this into the calculator? What's that? Oh, say that louder. Log 12 of log 4. Type that in. So there are actually two ways to type this in. Alexis is using the change of base. Okay, so she said the log of 12 of the log of 4. Do you see how that works? Okay, there's another way that you can actually type it into the calculator using the base notation. Okay, and if you hit, let's hold on, let's see if I can remember. Alpha, there it is, alpha window. You see that fifth option down? The calculator can actually work with different bases, and now it looks exactly like you see it on your page. Okay, so we can type it in as log base 4 of 12. Okay, and we should get the exact same value. Okay, so whatever way floats your boat, you're going to get to the same spot. What's your last step in solving for the x? Subtract 2. So if we just hit minus 2, whoops, minus 2, we find that our x value is negative 0.207. Super? What part is not super?
So I got.
Yep, and then, yep, and then minus 2, because we're just finishing solving the equation.
So do you graph?
Like to solve them? Is that what you mean? Or are we going to graph logarithmic functions?
Solve by graph.
Absolutely. We can set y1 as your left side and y1 as your right side, and where those intersect will be exactly at negative 0.204, whatever that number is. Yep. All right. You need these properties. Where are they? Okay, we did talk about these properties last year. I don't know if you remember them. I guess this is up to you if you want to write them down or not. If I were you, I would probably. Okay, these are logarithmic properties, and notice that they wrote these all with natural logs. Okay, I didn't talk about natural logs before. Do I need to talk about natural logs? What kind of base is a natural log always in? In the base of e. Okay, so e is that number 2.718. Oh, those remember it. I used to remember it longer, but anyways, some number. Okay, but you can write these properties with LOGs or of any base. It doesn't matter. As long as they have the same base, these properties still apply.
What's rule 2?
What's that?
What's the rule 2?
Oh, technically a reciprocal rule is using the quotient rule because if you were using the quotient rule on this side and just saying that this would turn into the natural log of 1 minus the natural log of x, well, the natural log of 1 is 0. So you just get 0 minus the natural log of x. So that's what they're saying. All right, is everybody good with that? Wrote it down? Check. Oh, Chess has a hurt finger, so.
All right, I'm good.
All right. So let me know if it is necessary for me to do more examples than this. I was just gonna show you some quick examples. I did this last time. Okay. So for A, okay, basically you would be working within two different forms. Okay. So there's condensed form and there's expanded form. Okay. So the expanded form is when you see more than one log. Okay, this side would be in condensed form. Okay, so can you tell me how they go from this left-hand side to the right side? Which property do they use? The product, right? Okay, so if I have a plus sign in between two logs, all we have to do is multiply the 4 times the sign. Notice how they throw some trig in there just for fun? Super fun. Okay. Okay, what about B? Which property is that? The quotient, right? So two things are being divided. Now, look very careful on this. Notice that when you have a top and you have a bottom, the top piece stays together as a quantity. This cannot be separated at all. Okay, so it's the natural log of x plus 1. Okay, minus, because of the division, the quantity, or 2 times the quantity of the natural log of 2. Oh my gosh, you can read and I cannot. Okay. So there you go. See, which property is that one? Okay, reciprocal, or one might argue, quotient. Right? They're really the same thing. Okay, I would suggest you write these 2, well, technically 4, quick little inverse properties. Okay, this helps you in reducing expressions. Okay, so notice when you have bases that are the same, they like end up canceling out when there's a log involved. There you go. And do you notice those intervals? Did you guys know that you can't work with a negative base? Logs can never be negative, unless, of course, they're reflected over the y-axis with a negative in the front. Good? Okay. There's the change of base formula if you feel free to write that down. That's Alexa pointed that out earlier. Let's see. I feel like for the most part you guys have this. Do I need to talk about inverse trig functions? I'm not going to go over all of those, but do you remember what the inverse of sine is? Inverse, not reciprocal, inverse. Okay, so if I have the equation y equals, equals sine of x. X is in reference to what? What kind of thing is the x? It's an angle, right? Usually you see it written as theta. Okay, it's representing some angle. Okay, well the inverse would look like this. So you'd have theta is equal to the inverse of y. Okay, have you guys heard of the arc sine? No? Okay, so arc is the same as the inverse of sine. Okay, so these two things are saying the exact same thing. Your calculator, depending on the calculator you're using, your calculator here sees inverse this way, but there are different calculators like Desmos would call this arc sine, and you can graph that function. Okay, so I'm going to leave it at that. All of your functions have inverses, so inverse of cosine is arc cosine, inverse of tangent is arc tan, okay, and so forth. Okay, that's all I'm going to say. I'm out. So one